Hello everyone. In this video we are going to take a quick introduction to pointers and to show that they're not really too bad. Pointers can be thought as kind of dangerous, but only if you use them incorrectly. And here I hope in the series of videos that follow, I'm going to teach you how to use pointers more correctly, hopefully perfectly correctly, so that way you don't generate segmentation faults and cause errors like that. So why don't we start with a quick program called showing pointers or show pointers. So here I have an empty C program, and if I was to create an integer, let's say int I equals 1, what happens with this variable? So this variable will actually live in an address inside of your computer hardware, and at that address it'll have a value of 1. So if I wanted to print the value, I would use good old printf %d, and we can give it a new line, and I would print I. Then we can compile and run this code, which will print the value of I. So one thing that I can do with pointers is, well, pointers have a value that's an address, and each variable has an address. So why don't we start by seeing the value of the address that we are accessing. Computers only see variables as addresses, while the variable names we just see as humans. So why don't we show that? In order for us to print the address of a variable, we need to use %p. I'll separate it with a comma. Now we'll use the address operand, which is %, and do %i. %i will allow us to see the address of I, and then we'll also be able to print the value of I. So we use %p to print a pointer value, and a pointer value being the address of a variable, which is given to by the ampersand operator, %i, and then I use %d to print an integer, which is I. So let's see that result. So it looks like here we have some weird number. This is a number that's presented in hexadecimal, and it is the address in memory of your computer, or of my computer I should say, where I, the variable I, is stored. So this is interesting. So it turns out every variable that you've used has an address. So that's pretty neat. So let's go back to the question. What's a pointer? And more importantly, how can I use it in my C programs? Well, if I wanted to create a pointer as a variable, I need to pick the data type that it's going to point to. In this case, is going to be an int, and I need to put a star symbol and give it a variable name. So on line 4, I have an integer called I, and on line 7, I have a pointer to an integer called x. And by the way, doing that and also doing int with the star next to it, these are both equivalent statements. You should go with the documentation that's consistent with the software that you're working on. So if the project requires that you do the star symbol, the asterisk, next to the data type, then you do it. If they require it next to the variable name, then you do that. You should always follow the standard documentation for your project. With that being said, x has no value, unlike I. However, it does have an address. So I can print, and let's say address of x, and I can give it the address of x. And actually, let's be a little bit more clear here. So address of I, value of I. So let's see what result this gives us. So variables cannot have values, but if they're created, they will have addresses. And if you do a little math, you will actually see that the variable x is right after the variable I. So what kind of values can go into pointers? Well, addresses. So if I wanted to give x a value, I need to give it an address. Well, the way I can do it is that I can give it the address of I. So x's value is the address of I. So here's what makes a pointer a pointer. So by giving x the address of I, x is pointing to I because it has its address. So why don't I go about printing the value of x now? On line 8, I just print its address. I did not print its value. If I wanted to print its value, I'd probably get junk, as you would if you print a variable that has no value. So I'm going to get rid of this. I'm going to have my other print statement here. Oops. And I'm going to say comma space value of x. I'm going to say %p, and we'll give it a new line. And I'll just say x. Let's see what results we get. Oh, and it looks like our address has changed. That's pretty cool. But here we have the address of I, and it has a value of 1. Now we have the address of x, which is its own address. But look, if we look at the value of x, the value of x is the address of I. So the nomenclature, the jargon, or the slang for this is saying that now x points to I. Well, if x holds the value, I'm meaning the address of I, can we use that to get the value of I? The short answer is yes. And how we do it is by doing something called a dereference. And I can say value of I from x. We can give it a new line. And what I'm going to do now is I'm going to dereference x. So since x has the address of I, it can access the value at that address if I dereference it. And I do that with the asterisk and x. So this is called dereferencing, which is different from here where I'm just creating a pointer, which both of these are different from the multiplication because we use the same symbol for multiplication. Right? So the multiplication has just gained two different contexts where it can be used. The first context is where it can be declared as a pointer, which is on line 7. And here it can be dereferenced, like at the end of line 11. So now let's see what the result is. The value of I from x is 1. So that's really, really cool. And if you see here, the address of x is the value of x, which makes sense because x is pointing to I. And when we dereference this address, we get the value, which is really, really cool. Now, this neat concept does not only apply to integers. If I wanted to, I can do the same thing with floating point variables and double variables. And here we have it. So on line 13, I create a floating point variable called f, and on line 14, I create a double called d. So next, in between lines 16 and 17, these are quite important lines. So on line 16, I create a pointer to a float called y. And on the next line down, on line 17, I have the value of y contain the address of f. So because y contains the address of f, y points to f. So here I've done the declaration on one line and I assigned the value on another line. And here this is one way of creating pointers. Equivalently, and actually, how about I just change that? I can take this, move that here. So the same way I can declare a variable as I did with f, I can declare a pointer like I did with y. And in the same way that I can assign a value to f, I can assign an address to y. Right? So these parallels are still the same. Both of these ways work. And when I go down to double, I do everything in one line. I do the declaration and I give it the initial value. So I do some initialization here. I do the initialization in one line, and here I can do the same thing with pointers. So here I wanted to show how I can declare pointers like this, and I can declare pointers like this, and it's a matter of style. So what happens with these next four print statements? Well, the first two print statements show what's going on with f and its pointer y. So we print the address of f, and then we print the value of f. We're able to print its address by using the ampersand symbol, otherwise known as the address operator, and then I'm able to print its value just by giving the name of the variable. Then on line 22, I print the address of y, the value of y, which should also be an address because it's a pointer, and then I print the value of f from y. So how I provide the address of y is by using the address operator, which is the ampersand. How I provide the value of y is the variable name itself, but because y is a pointer, I need to use the %p, and to access the value at the address that I'm pointing to, I use the dereference, so which is the asterisk symbol with y. So I'm dereferencing y to get the value of f. And I essentially do the same thing for doubles. I get the address by using %d, I get the value just by using d, and then here I get all levels of the pointer, the address of the pointer, the value of the pointer, and the value of the dereference of the address that I'm pointing to. So now let's see the result. So first let's take a look. So all this works. This is from my previous experiment, but now let's look right here. So the address of f, it has its value. Good. So the address of y is totally different because y is its own variable. It lives in its own place. And the value of y is also the address of f. So this is correct. We're able to correctly assign the value of a floating point address to a pointer to a floating point variable. And then I'm able to dereference to get the value of f from y. Then we take a look at d, and we realize that it's going to be the same with the values and the addresses themselves. So I hope this kind of sheds some light into pointers, and I'll see you in the next video where we will kind of talk about how dereferencing does a little bit more than just showing pointers, and also showing how we can do arithmetic with pointers. Thank you.